Hi, my name is Jordan Deschamps. I'm an engineer with Water Mission based in Charleston, South Carolina. And this is a video about step 1 of the Pumped Safe Water design tool. This is a new tool that we've developed at Water Mission to help design engineers work through the 5 steps of the design process. These training videos will give you an introduction to the design tool and each step in the process of designing pumped safe water systems. This first example that we will go through in this series of videos is of a solar pump project from Indonesia in a community called Kuimasi. Before we jump in, let me share a few reminders about the tool. The main design space is on the left side of the spreadsheet. Each step is broken into parts as you scroll down. The blue cells are for user input, so you can enter values in the blue cells. And there are also links to optional calculators and references as indicated by these yellow icons and blue hyperlinks, which will take you to other locations in the spreadsheet. Lastly, there is an optional space on the right side where you can enter notes for yourself or your own calculations. It's up to you to use this space as you wish, so feel free to use that. So the main question we're trying to answer here in step 1 is, what is the water demand of the population being served? There's 2 key components in that question, the population and the water demand, shown by these sub-steps, step 1A and step 1B. Now you might notice that this tab is very much simplified compared to our water demand tab that we've used in previous design tools. There's just 2 basic places where you can enter information. First, entering the population, and then answering the question, how was the design population determined? Similarly, there's a place to enter the water demand, and then a place to explain how the water demand was determined. Now you might be wondering, well, how do we calculate the population? That's where the optional calculators tab might be helpful. So let's click on that. Look, here we can see the design engineer entered the number of households in that community and the people per household to get a total household population of 650 people. So jumping back to step 1, the design engineer has entered 650, and they've based it on the number of households and the average household size, and they give a reference to see the optional calculators for household population. So next we can look at water demand, and again this number is already entered, but we might want to see and reference the optional calculators tab to see how it was calculated. And this highlights the section on the optional calculators tab under step 1 about household water demand, where we enter the household population. In the blue cell here, the total water demand per person, which is 60 liters per person per day. And then if there are any alternative water sources available, you might have a demand from that here, but the design engineer has left it blank. So the estimated water need is just 60 liters per person per day. And then the chosen water demand, which is based on the estimated water need, is also then 60 liters per person per day. So then that 60 multiplied by 650 people gives us the daily water demand from households, which is 39 cubic meters per day. And just as a reminder, these cells that have the red triangles in the top right corner have helpful notes and explanations that give definitions and guidance to these optional calculators. So if you're interested in learning more, you can hover your mouse over one of these cells to read more. But getting back to step 1, we can see they've entered the design water demand here of 39 cubic meters per day, and they've given an explanation that it's based on an average water use per person of 60 liters per person per day. Then at the very end, we get a summary of the main outputs or main data points from each step. And in this case, for step 1, we just get the design population of 650 people and the design water demand of 39 meters cubed per day. So we've reached the end of step 1. I hope you'll tune in to see more about step 2, which is about water supply. And as always, feel free to contact a Charleston engineer if you have any questions or need support using this tool. Thanks for watching.